On this one, we are starting section 6.3. And today, we are doing radical operations. Radical operations, when I say that, that means we are going to add, subtract, multiply, and divide them. We're going to have some fun with them. Yes, exactly. So, first thing I want to remind you, we can only perform any of these operations. Yes, if they have the same dimensions. Must have same dimension. No matter whether we are adding, subtracting, multiplying, or dividing, they must have the same dimension. Correct. We're going to first start by adding and subtracting. In order to add and subtract radicals, the radicals must be alike. Once they are alike, we can add coefficients.
What do you mean by alike?
I'll show you. All right, so just like if I were to have 2x plus 5x, those are like terms, right? And so I would add the coefficients on those because they're the same, and I would have 7x. When we're talking about radicals, if I have 2 square roots of 3 plus 5 square roots of 3, those radicals are exactly the same. They're like terms, and so we add our coefficients. We have 7 square roots of 3. So they have to be alike in order to add them together. Doesn't seem tough, right? Yep, exactly. Same exact thing whether we're adding or subtracting. So here's example number 1. And this is at the very beginning, 10 through 16. Yeah. Okay. Okay. So let's say I have 6 cube root of 3 minus 4 cube roots of 3. Are those like terms? They are. So all we do is subtract their coefficients. 6 and negative 4, we get 2 cube roots of 3. At the same time, let's say if I had... Huh? Nope, those just stay like terms. Just like if it was an x, it wouldn't change. So let's say I have 5 square root of 7 plus 3 square root of 7 minus 2 square roots of 7. 5 plus 3 is 8 square roots of 7 minus 2. So this would be 6 square roots of 7. Good try. All right? So we just add those coefficients. It's just like they're like terms. That's it. There's no tricks, no nothing. All right, let's go to example number 2. Example number 2. This is section 18 through 22. Let's say I have 6 square root 18 plus 3 square root 50. Can I add them the way they are? No, they're not like terms. But what we can do to them is first simplify and see if they become like terms. So 18 breaks down into 9 times 2. 9 breaks down into 3 and 3. Yeah, so 3 goes out and meets up with 6. So we have 18 on the outside. Left at home is a 2. Plus, here, 50 is 25 times 2. 25 is 5 and 5. So our group of 5s gets to go out and join the 3. So we have 15 left at home as a square root of 2. Now are they like terms? So we can add their coefficients together. Just going to add 18 plus 15, 33, and we keep the square root of 2. No, we're not multiplying together. We're just adding them. Okay? We're just adding them. It's kind of like saying I have like 3 square roots of 2 over here and 6 square roots of 2 over here. It means I have a total of 9 square roots of 2 all hanging out. What if you got something like this? Let's say I got 3 cube roots of 81 plus 2 cube roots of 54. Okay, so we can't add them together right now. So we got to simplify them. This time, how many friends am I going to need? 3. Good. All right. So in this first one, I have a group of 3s that get to come out. When they come out and join the 3 that's out there, we multiply the fun. I have 9 cube root what? 3. There's 1 3 left over. Plus 54 breaks down into 6 times 9. 6 is 2 and 3. 9 is 3 and 3. So I again have a group of 3s that get to come out and join the 2. 6. This time inside my cube root I have a 2. Are those like terms? Nope. So you have to stop there. You can't do anything else. Nope, don't say anything. You just stop. It's already simplified. You can say can't simplify if you want to, but you don't have to. It just stops. Okay, so do we have any questions on adding them?
So if the numbers on the inside are different than the edge, you can't.
Correct, you can't add them.
You should have learned subtraction and addition and subtraction before.
Well, we're going to get into multiplying even more now. Okay, so any questions here? Do you guys want another example of adding and subtracting? No. Okay. All right, let's go to multiplying. Multiplying. Oh, no, we multiplied radicals. Now we're going to multiply expressions with radicals. So if I multiply a monomial times a binomial, we distribute and simplify. If I multiply a binomial times another binomial, how do you think we multiply these? What's your favorite way to multiply binomials? No, that's division. How about we multiply in the box and simplify? Sorry. Told you it was going to stick around forever. All right, so here we go with example number 3. Simplify. Let's say I have the square root of 3 times the square root of 6 minus the square root of 15. You want one of those? Yes. You're welcome. All right, so now, because it's a monomial in front, we're going to distribute. Square root of 3 times the square root of 6 is the square root of 18. Square root of 3 minus the square root of 15. We get outsides, we get a negative. Insides, we get the square root of 45. Now we have to simplify them. The square root of 18 breaks down into 9 times 2. 3 and 3. So our group of 3's come out. 2 stays home. Minus 45 is 9 times 5. 3 and 3. So group of 3's comes out. 5 stays home. Is there any more I can do to this? That is it.
Beautiful. How many more? Yeah, it's already in the box. No,
This
if
was-
it's if it's two binomials.
Yeah, if it's 2 binomials. That's what we put at the top of that section, right? This was a monomial times a binomial. So example number 4, any guesses what that's going to be? Yeah. Example number 4 is 24 through 28. Probably 2 or 3 more. Okay? After this one, 2, probably 2. I think I can get it done 2, maybe 3. All right. So let's say I have 3 plus the square root of 2 squared. Got to box that, exactly. This is the same as saying I have 3 plus the square root of 2 times 3 plus the square root of 2. So I'm going to put it in a box. 3 plus the square root of 2 times by 3 plus the square root of 2. 3 times 3 is 9. 3 times square root 2 is 3 square root 2. 3 times square root 2 is 3 square root 2. Square root 2 times square root 2 is just 2. Now you'll notice when we do these, the diagonals add together both ways. All right, so 9 plus 2 is 11. What is 3 square roots of 2 plus 3 square roots of 2? Correct. Very good. Yeah. Example number 5. This is from section 30 and 32. All right, I want you to multiply. Let's go with 5 minus the square root of 7 times by 5 plus the square root of 7. What do those look like? What do you notice about those two? Okay, they're identical except for the sign in the middle. Does anybody remember what those are called? We used them when we were working with I. It starts with a C. We call them conjugates. Conjugates. The diagonal should cancel out. That's the idea of a conjugate, right? Let's see what happens. I have 5 minus the square root of 7 times 5 plus the square root of 7. All right, 5 times 5 is 25. 5 times negative 7 is negative 5 square root 7. 5 times the square root of 7 is 5 square root 7. Negative square root 7 times positive square root 7 is negative 7, right? We got to keep our sign. Okay, negative 7. So now what do you notice about our diagonal? It does. When they're conjugates, that's always going to cancel. Yes, so we get 25 plus negative 7 is 18. Okay, questions so far? Now, does anybody remember when we used conjugates? What were we doing that we had to use a conjugate? We were using I. What else were we doing with I? We were doing boxes. What else? Not plus and minus. Okay, remember that we had to use the conjugate to get rid of I in the bottom of a fraction. It does. So we're going to talk about dividing. All right. Dividing radicals. You have to multiply by the conjugate. Going to remind you, if I have 3 minus the square root of 2, the conjugate is 3 plus the square root of 2. That's J-U-G. Oh, well, that dot is supposed to be over there. Sorry. All right, if I have negative 5 plus the square root of 3, the conjugate to that is negative 5 minus the square root of 3. If I have, how about 7 plus 2 square root 2, the conjugate is negative 7, or not negative 7, sorry, 7 minus the 2 square root of 2. Okay? So the conjugate just changes the middle sign and that's it. All right, so here we go with example number 6. Let's say I have 3 over, let's go 2 square root 3 plus 1. In order to get rid of that radical in the bottom, I have to multiply by the conjugate, which is 2 square root 3 minus 1. Whatever we do to the bottom, have to do the top. That's right, Parker. All right, whoops. There we go. So now on the top, I'm just distributing. 3 times 2 square root of 3 is 6 square root 3. 3 times negative 1? Negative 3 over. What do I do with the denominator? Put it in the what? Yeah, I have 2 square root 3 plus 1 times 2 square root 3 minus 1. 2 square root 3 times 2 square root 3. 2 times 2 is 4. We get square root 3 times square root 3 is technically square root 9, which comes out to be 3. So 4 times 3 is 12. Did everybody understand how we just got 12 there? Okay. 2 square root 3 times 1 is 2 square root 3. 2 square root 3 times negative 1 is negative 2 square root 3. 1 times negative 1 is negative 1. What do you notice about the diagonal? Yeah. And what do we have left? 11. And we're done. Huh? That's it? Nope, that's it. So, we did these when we had eyes in the bottom. Do we need to do more of them now? We're okay? You guys are ready to start your homework? You need to start it, or I can keep talking. Better start the homework? Okay. Yes.